All right, everybody, we are in Chapter 1, Lesson 1 on page 7. And for learning objective A, we are finding greatest common factors. And for learning objective B, we're finding least common multiples. For this lesson that we're doing right now, we're just going to start with the greatest common factors. We'll come back later and do multiples. So let's focus on greatest common factor. Right here it says a common factor is a number that is a factor of two or more numbers. The greatest of the common factors of two or more numbers is called the greatest common factor. Now, that is kind of confusing. So let's break down these words. First of all, GCF, you're going to see that a lot. Instead of writing out greatest common factor, we're just going to write GCF. So GCF stands for greatest common factor. Now, greatest means what? It's like the bigger number, it's like the most. And then common would mean something that things have in common or things are the same. So we're going to be looking for the same big most number, but we're talking about factors. So what are factors again? Remember, factors are numbers that get multiplied together. So if you had like 2 times 3 equals 6, 2 and 3 are the factor numbers. So factors are numbers that are multiplied together. So basically, you can take a number and you can break it down into its factors. If you had the number 12, you could break that into factors like 2 times 6 equals 12, or 3 times 4 equals 12, or 1 times 12 equals 12. So all these different numbers are factors of 12. All right, we're going to skip the least common multiple stuff for now and turn to page 8. And let's just focus on page 8. So this is our lesson that we're going to do together. Whatever I write, you are going to write. So follow along with me first. Let's just do a little reminder here that you need to know what prime numbers are. It says, remember, a prime number is a whole number that has exactly 2 factors, 1 and the number itself. So let's talk about that for a minute. You have the prime number 3. That can only be broken down into 1 times 3. Whereas when we had 12 over here, you had a lot of different factors. You had 1 times 12, but you also had 2 and 6 and 3 and 4 as factors. So a prime number is a number that only has 1 and itself as the number, as factors. 7 would be another one. 7, you can only do 1 times 7 to get 7. You can't do, 2 times another whole number to get 7. All right, so it says find the greatest common factor. You can use common factors or prime factors to find the greatest common factor. So these are going to be our 2 methods. So there are going to be 2 methods. Common factors, that's going to be called the list method. And prime factors, we're going to call that the factor tree. So let's write this in. This first part of the page, this first example, is going to be method 1, which is the list method. And down here, this is going to show us lesson 2, or method 2, which is the tree method. So let's come up here and start with the greatest common factor method 1. So write this in, GCF method 1, and that's called the list. So one way to find greatest common factor of 2 or more numbers is to make a list. So the first thing that you do is you list all factors, and then the second thing you do well, I'm going to say list all factors of each number. And then with the two numbers, you find the factor, the greatest factor that they have in common. So circle the greatest factor they have in common. Now let's just look over here and see what that looks like. There's a little story problem here, and I'm going to talk to you about story problems because there are key numbers or key words that you look for in story problems for greatest common factor. Follow along with me. It says there are 1 slice servings of 3 types of cake on a table. So you have marble cake, velvet cake, and chocolate cake. Each row has an equal number of servings and only 1 type of cake. So you've got this cake set out on a table in rows. Each row has an equal number of servings of cake, but there's only 1 type of cake. That's really confusing. Here's your key word that you want to look for. What is the greatest number of servings in each row? This word right here, if you get a word like greatest or most, then you'll know we're looking for greatest common factor. So let's see how the book solves this problem here with a list. It says to solve the problem, use common factors. And what they did was they listed out the common factors. So factors of 10 would be 1 times 10 equals 10. 2 times 5 equals 10. Now, I personally like to list it out like this. I'll say, okay, factors of 10 are, I always start with 1. It would be 1 times 10. And then I go to 2. 2 times 5. Then I think 3. You can't do 3 times a number to get 10. 4 times, there's no 4 times anything to get 10. And it's 5 times 2, so we're just back where we started. So this is how I like to list it. Some people like to list it this way in like a rainbow. Maybe you've talked about this before where you have, okay, 10 is 1 times 10 and 2 times 5. And here's my list of factors. So maybe you like to do the rainbow list, maybe you like to list it like this, or maybe like me, you like to list the factors out like that. Honestly, you can do it any of those ways when you're listing factors. Look at how they listed factors of 15. So I would always start with 1 times 15, and you see those here. And then I'd think 2 times something. No, what about 3? 3 times 5 is 15. And there's no 4 times anything to get 15, and then you get 5 again, so that's where you end there. And factors of 20 are listed out here. I always think, okay, there's 1 times 20, and then 2 times 10, and there's no 3 times something to get 20, but 4 times 5 equals 20, and then 5 times 4, so then you just kind of restart the numbers. So step 1 is to list all the factors. Step 2 is to circle the greatest factor they have in common. So of all these numbers, they have in common only 1 and 5, and which one is the greatest one? 5 is greater than 1. So I would circle 5. 5 is my greatest common factor. So the answer to the story problem is the greatest number of pieces of cake that can be placed in each row is 5. So again, any way you want to list it out is fine. If I was listing it this way, I would say, okay, they all have 1s, only those have 10s, only those 2 have 2s, they all have 5s, and I'd circle that. The only time this method can do you wrong is if you forget one of the factors in your list. If you forget one of the factors in your list, then you might end up with the wrong answer. Other than that, this one I think is a little easier than method 2. We're going to practice this list method one more time right here. So here's another story problem. Let's look for that key word like greatest or most. Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? There's that key word here. So we're trying to break this down. If this is her total, we're breaking it down to try to find how much she was charging per bracelet. So let's make the list. We have our three numbers, 49, 42, and 21, and we need to list out the factors for each number and find the greatest one they have in common. So I always start with 1. 1 times 49, those would get you 49. Now, you can't do 2 times something, or 3, or 4 times something, 5 times something, 6, 7. 7 times 7 is 49. And then it gets you back to 7, so that's it for 49. What about 42? 1 times 42, and then let's think 2. You can half that because it's an even number. 2 times, half of 40 is 20, half of 2 is 1. So 2 times 21 is 42. What about 3 times something? I don't think so. 4 times, I'm thinking it gets up to 6. 6 times 7 is 42. Okay, what about 21? You have 1 times 21, 2 times something, 3 times 7. 3 times, 7. Can't do 4 or 5 or 6. So those are all our factors. Now we need to circle the greatest factor they have in common. They all have 1s. This is the only one with 49. This has 7, this has 7, this has 7. So 7 could be an option. And then it has to be 7. So the greatest common factor is 7. So what's the most she could charge for each bracelet? $7. Okay, so this is the listing method. Make a list of all the factors and then find the greatest number that the original numbers have in common. Man, it's so hard to describe this first lesson, greatest common factor and least common multiple. All right, now we're moving on to method 2. So right here, greatest common factor, method 2. And that is what we call the factor tree. And what we're doing in a factor tree is we're looking back to find prime factors. So we're going to break down the numbers until we get to the prime factors. So number 1, step 1 for this method is to break down. Is that okay for down? Break down numbers into prime factors. All right, step 2. So they broke down the numbers. So you have 12 can be broken into 6 times 2 is 12. 2 is a prime number. So I'm just going to bring that down. 6 can be broken down into 3 times 2. 3 is a prime number. 2 is a prime number. So 3 times 2 times 2 can get you 12. Those are the prime numbers. Then you break down 18. 9 times 2, 2 is prime, but 9 can be broken down into 3 times 3. These are all prime. So that was step 1. Step 2 is to circle common prime factors. Okay, so look at 2 and 3 are common prime factors. This has 3 and this has 2. They only each have 1, 2, and 1, 3 though. So this 2, there's not another 2 over here. Or this 3, there's not another 3 over here. So I like to even say, okay, these 3s are here and these 2s are here. Now, step 3 is if you're in a situation like this where you have more than one common prime factor, if you have more than one, then you have to multiply the common prime factors. So we're going to write multiply the common prime factors in parentheses if there are more than 1. So in this case, we had common prime factors being 2 and 3. So 2 times 3 is 6. 6 is your greatest common factor. That would be your answer. But sometimes you don't have more than one common prime factor. And let's put an example of that right here. So if you had 12 right here, and instead of 18, what if you had 14? So write this out. We already know 12 tree is right here. So it ends up with 3 times 2 times 2. But let's break down 14. Let's do 2 times 7. 2 is prime. 7 is prime, right? So 2 and 7 are both prime. Look at 12. 12 got broken into 3 times 2 times 2. Okay, so they only have a 2 in common. So the greatest common factor here is 2. You don't have to do any multiplying because there's only one factor that they have in common. Now, we're going to practice this 3 times, and then you're going to decide which method you like more, the list method or the factor tree method, and you're going to pick that for the guided and independent practice. You get to pick your method. But let's try this one a little bit more. Some people get afraid of this method, but honestly, the good thing about this method is people make less mistakes, because up here sometimes you forget factors, but down here you break it down to the prime factors and you usually can't mess up. So here we go. Let's do B together, and let's show our work here. So we need to make a little tree for 12, which we already kind of did up here. Look, I'm going to try something different. I'm going to do 3 times 4, and we should still get the same answer. So 3 times 4 equals 12. 3 is prime. 4 can be broken into 2 times 2. So these are all prime. Let's do 66. Let's see here. 6 times 11, that would be 1. You could do 2 times 33. No matter what, you end up with the same number. So I'm going to do, the bigger numbers are better because there's less tree to do. So 6 times 11. Now 11 is prime, but 6 can be broken into 2 times 3, and then you just have to bring down the 11. So these are all prime. Step 2 is to circle the common prime factors. So they both have a 2 and they both have a 3. And so we've got the 3 and the 2 and the greatest common factor. Step 3, multiply the common prime factors, is 3 times 2, which is 6. So 6 is our greatest common factor for B. All right, now let's do the tree for 18 and 30. So let's make a tree for 18. Well, you could do 2 times 9, right? 2 times 9. 2's already prime. 9 can break down into 3 times 3. So 2 times 3 times 3 gave us 18. Now let's break down 30. Now you could do this different ways. 2 times 15, 3 times 10. The bigger the better. 6 times 5, that's a nice big one. 6 times 5. That's going to give us 2 times 3, and 5 is already prime. So these are all prime, these are all prime. What do they have in common? A 2 and a 3 again. So I take the 2's and I take the 3's, and my greatest common factor is step 3, multiply the common prime factors. So that's 6 again. Going to be creepy if this one ends up being 6. All right, let's do this one. 32 and 48. So 32, what times what equals 32? I'm thinking 4 times 8. There are a lot of different options though, right? 2 times 16. Okay, so those are not prime. 2 times 2, those are prime. And this would be 2 times 4. Okay, now we can break down 4 though. So you bring down the 2, you bring down the 2, you bring down the 2. This breaks into 2 and 2. So, wow, that's a lot of 2's. Let's break down the 48 now. So when I think of 48, I'm thinking what, 6 times 8? And again, it doesn't matter how you break it down because you're going to end up with the same prime numbers at the end. So 6 can be broken down into 2 times 3. 8 can be broken down into 2 times 4. And you just put your little multiplication in between because 2 times 3 times 2 times 4 ends up getting you 48. 2 times 3 is 6. 6 times 2 is 12. 12 times 4 is 48. So this is prime. This is prime. This is prime. 4 can break down into 2 times 2. Now, all of these are prime. All of these are prime. We have to circle the common primes. There's 1, 2, 3, 4 2s. 1, 2, 3, 4, 5 2s. So 4 of these are common. 1, 2, 3, 4. So to get our last step in here, multiply the common prime factors. The greatest common factor is 2 times 2 times 2 times 2. 1, 2, 3, 4 2s. Now think about this. 2 times 2 is 4. 4 times 2 is 8. And then 8 times 2 is 16. So 16 is our answer. So you can pick one of these. You can pick the list or the tree method. And if you like both of them and you want to try both of them for the guided practice, you can go ahead and do a mix of both of them. But what we're going to do next is skip page 9. That talks about multiples. We want to stay with factors. Skip page 9 and go all the way to page 10 where it says guided practice. And this is where you're going to partner up. So if your table partner isn't at the same spot that you're at right now, raise your hand and the teacher will help partner you up or tell you what to do while you're waiting for your table partner. All right, so let's talk about how guided practice works. We are going to do, for our little to-do list, it says that we're going to do number 1 and number 2 for the greatest common factor. These other ones all have to do with least common multiple. So we're not going to do number 3. We need to show our work. We can either use the list or the tree, and we need to find the greatest common factor of each set of numbers. So what I want you to do is, you and your partner, you find the answer to number 1, and then watch this video and see if you're right. Find the answer to number 2, then watch this video to see if you're right. If you get stuck, look back and see how we did these 2 methods here and use those 2 examples and the examples that we did together to help you out. So go ahead and do number 1, pause this video, and then play it to watch and check it. So this is how I would do number 1 if I was doing the list. So the first method is going to be the list method, and then I'll show you the tree method. 8 and 32. Let's make a list of the factors. 1 times 8, 2 times 4. There's no 3 times anything, so that's it. 1 times 32. This could be 2. Half of 30 is 15. Half of 2 is 1, so 2 times 16. Is there 3 times anything? I don't think so. There's 4 times 8. No, 5. What about 6? Nope. So that's good. Now, the second thing was circle the greatest factor they have in common. So they both have 1s. They both have 8s. They both have 2s. So 1, 8, or 2. 8's the greatest. So our greatest common factor here is 8. All right, now, if you did the tree method, I'm going to show you that right here. So this is the tree method. We have 8 and we have 32. So I'm thinking 2 times 4, that's prime. 2 times 2, those are all prime. And for 32, I'm going to use 4 times 8. You could have used one of these other ones, that's okay. 2 times 2, those would both be prime. This would be 2 times 4, prime, prime, prime. 4 needs to be broken down again. So the next step is to circle the common ones. So 3 2s here and 3 2s here. Now we take the first 2, the second 2, and the third 2 and multiply them together. So 2 times 2 is 4, and 4 times 2 is 8. So there you go, you get the same answer. All right, now with your partner, do number 2. You can use the list or the tree method, and I'll show you both when we go to check it. All right, so first, pause the video, push play when you're done. Here's how I would do the list method, 24 and 60. So I always start with 1. 1 times 24, there's 2 times 12. What about 3 times 6 and 4 times 8? There's no 5 times anything, or 7. Okay, let's do 60. 1 times 60, 2 times 30, 3 times 20. What else? What about 4? 5 times 12, right? 5 times 12. What about 6 times 10? And I think that leaves us. See, this is the tricky one. You know what? Another suggestion is you can look at your multiplication charts for this to make sure you didn't miss anything. All right, so we're going to circle the greatest common one. They both have 1. They don't have 24. They both have 2. They both have 12, 3, 6. So the greatest number here that they both have is 12. Now let's see if we get that same number for our factor tree. If you did the tree, 24. Let's use 3 times 6. Why not? Oh, did I mess that up? 3 times 8, 4 times 6. Oh, I always tend to mess something up. Let's do 3 times 8. All right, so this is prime already. And 2 times 4, that's not prime. We need to break that down. The 2 comes down, the 3 comes down. Okay, those are all prime. Now, 60. Let's use 6 times 10, how about? So this would be 2 and 3. This is 2 and 5. All right, all prime. So they both have a 2. They both have a 3. They both have a 2. So 2, 3, and 2. Greatest common factor is 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12. There you go. All right, now you're done with your partner work. You can stay where you're at in case you want to touch base with your partner, but the next step is to move to page 11. And on page 11, you're going to do the independent practice. Independent means you're on your own. So for the independent practice, you are going to do number 1, number 2, and number 9. And look at number 9. A gardener has 27 pansies, 36 daisies. He plants an equal number of each type of flower in each row. What is the greatest GCF possible number of pansies in each row? So you're just doing these 3. You can use either method. You don't have to use both methods. Just pick a method unless you want to do both. And go ahead and move on to those 3. When you're done, you can play the video and check your answers. All right, let's check your work, and if you have any questions, now is a good time to ask if you can't figure it out from the video. So the greatest common factor is 2. Here's how I did the list, and here's how I broke down the tree. They only had 1 factor in common, so you didn't have to do any multiplying here. For these 3 numbers, here's my list. 3 was the greatest common one. In the tree, again, they only had 3 as a common factor, so you didn't have to do any multiplying there in the tree either. This one down here, number 9, here's my list. 9 was the greatest common factor. So 9 pansies is the answer. And over here in the tree, they did have 2 3s in common. So the greatest common factor is 3 times 3, which is 9. Now, your next step is going to be in your math journal. Check off on your to-do list. But the next thing on the list is this right here, the reflection. So here's the thing about the reflection. Try not to use your math book when you do this. But if you need to go back to your math book and look at the notes that you took, that's okay. But this is kind of like a little test to see where you're at after you've done all of the lesson and the guided and independent practice. So try not to use your math book. Here we go. The learning objective was I can find the greatest common factor of 2 or more numbers. For number 1, fill in the blank. I like to find the greatest common factor of 2 or more numbers using the blank method, the list or the factor tree method. What's your favorite? And for this method, describe what you do. So in complete sentences, what is it that you do in the list, or what is it that you do in the factor tree? And then for number 3, here's an example of how I show my work to find the greatest common factor of 12 and 18. So again, just this method that you prefer, that's the one you need to use down here. Don't worry about using both methods. All right, when you're done, check the board to see what's next, but the teacher is going to need to check this.